Hi guys, I wanted to talk to you a little bit on our e-learning day about rational exponents. If you want to take notes along with me, feel free, or you can keep coming back to this video to get more information. The root of the word rational is ratio, and so what that really means is I have a ratio for my exponent. In other words, we have fractions. And what does that mean? When I have numbers and the exponents on them are fractions. First I want you to think to yourself, what could you square and get the result to be 5? Think. What could I square? The answer has to be 5. It might be easier if I would have asked, what could you square and get the answer of 16? Because 16 happens to be a perfect square and you would have known the answer is 4. We can do the same idea with 5. It would have to be whatever the square root of 5 is, and that happens to just be irrational. So I can take the square root of 5 and square it. Those are inverse operations, and I get 5. Likewise, what could I square and get the result of x? Well, using the same principle up here, it would have to be the square root of x. Now I'm going to challenge you. There's a whole other way to think about this. What else could I square and get x? And this would happen to use our laws of exponents. So if I can somehow, this has an exponent of 1. If I can somehow apply the law of exponents where I have a power to a power, I know I get to multiply my exponents, and I need the result to be 1. So what can I multiply times 2 and get the answer to be 1? That would be a half. So here I took two things, they look different, square root of x versus x to the half, but when I square them, I get the exact same answer, x, both times. And so using those two pieces of information, I can come to the conclusion that when I write the square root of x, or if I write x to the 1/2, they are the same number. And I could use the same principle to say, okay, well, what could I cube to get x? Well, it would have to be the cube root. Since I don't know what x is, I couldn't give you a numeric answer. But I know that cubing and cube rooting are inverses, and it would leave me with just x. I could also use my laws of exponents to say that I could do a power to a power, and I've got to get 1 for my result, so that could be x to the 1/3. 1/3 times 3 gets me 1. And so here, from these two pieces of information, I now know that writing the cubed root of x is exactly the same as writing x to the 1/3. And if we follow that idea, we could continue on, and we could say, well, writing the 4th root of x, any number, is the same as doing that number to the 1/4 power. Or the 5th root would be to the 1/5 power. So now if I apply this and do some examples, and let's say I have 81 to the 1/2 power. Okay, essentially what that means is I'm doing the square root of 81, and my answer would be 9. What if I take 81 to the 1/4 power? Okay, think in my head, that means I'm doing the 4th root of 81. And here's where it comes in handy to have your powers memorized, and I don't have all of mine memorized, but I have this nice little toolbox I made for myself a long time ago. And I have all my powers of 4 organized here until I got to 625. I can see 81 here, it required me to do 3 to the 4th power. So the number that I have to do 4 of to get 81 is the number 3. So the 4th root of 81 is 3. I could say, well, what's 27 to the 1/3 power? Well, that is the cubed root of 27. Use my little toolkit. If I don't know that, here are all my perfect cubes. To get 27, it required me to do a 3. So that would be a 3. Okay, continue on. What if I would try to do 216 to 1/3 power? Now, without continuing to write my little thought bubbles, I'm doing the cube root of 216. And so if I look at my little index card, 216 here required me to do 6 cubed. The answer would be 6. One more simple one. 32 to the 1/5 power would be asking me to do the 5th root of 32. And when I look here, my power is a 5. 32 requires me to do a 2 to the 5th power. So the answer is 2. Now, we can get a little more involved in this, because they could start giving me fractions that aren't just 1s for all the numerators, such as, well, what would 8 to the 2/3 power be? If I use my law of exponents, I'm going to think of this as really 8 to the 1/3 squared, because when I have a power to a power, I would multiply those exponents, and 2 times a 3rd gives me 2/3. So now I'm thinking I really just need the cubed root of 8, which I know to be 2, and then I'm going to square that answer, and the answer is 4. So 8 to the 2/3 power is 4. And if I continued this on and I did a 16 to the 3/2 power, I'm going to think to myself, well, if I use my law of exponents, that's 16 to the 1/2 power cubed. Because when I multiply that, I get 3/2. I happen to know that a 1/2 power means to do a square root. Square root of 16 is 4, and 4 cubed is 64. And that's our result there. So if I generalize this idea, and I have any number, call it a, to the p over r fraction for the exponent, I know that means I'm going to end up doing the rth root of a, whatever it is. If that's a 5, then I'm doing the 5th root. If that's a 10, I'm doing the 10th root. And then I'm going to take that to the p power. Or if for some reason you wanted to, you could do the power first and then do the root after that. But I don't really want to make my number larger and then do a root. I normally do it in this order, take the root, and then I'll do the power. So I hope you can use this to apply to the practice problems I've left for you. Good luck!